Hello. Once again, physical science fanatics, teachers, learners. So we're back again with another interesting section, which is your chemical properties, which deals with chemical reactions. We will also tap into reaction rates in the same presentation. Now we have got a recent question paper here, which is question number 4, which says 3 organic reactions 1, 2, 3 are represented below. Study the reactions and answer the questions that follow. Let's study the reaction first. As they say, P and Br2 have got 1,2 dibromobutane. Once you've got 1,2, mean that both bromine atoms were accommodated in the structure. This must be an alkene, which will be your but1-ene. And then number 2, we have got the ethanol. Then once this one is ethanol, we know that ethanol can undergo 2 reactions. This one says but1-ene. Ethanol can undergo 2 reactions. One of them will be substitution or elimination. This once you've got 2 products, then that's elimination. Then this one will be ethene. Fine. Q and R. Q, which is ethene. So ethene can undergo only 1 reaction, that is addition. Therefore, we are adding from saturated, then we'll be adding hydrogen. Don't forget, this type of reaction requires a catalyst. Can be platinum, nickel, or even palladium. So hopefully you will remember that. Fine. Let's go to the questions. Number 1, they say 4.1. For reaction 1, remember reaction 1 we said it's addition. Rather than the UPEC name of P, we said we have already analyzed that one is but1-ene. But1-ene. Fine. 4.2 or 1-butene. 4.1.2. Now write down the 2 types of intermolecular forces found between the molecules of the product. Remember, the product is a haloalkane. 2 types of intermolecular forces there will be haloalkane is having your hydrogen bond. All compounds have got I've got your London forces, and then this one, because haloalkane will have your dipole forces in addition. Dipole forces. Thank you. And then 4.2. Now it says for reaction 2, write down the type of reaction. So reaction 2 is elimination. Therefore, that will be your typical elimination. Because we are forming an alkene. 4.2.2. And now we have got, they say to us, write down 2 reaction conditions for elimination. Remember, this one is dehydration. We need concentrated sulfuric acid, and then another reaction condition must be just heat in this case. Fine. 4.2.3. 4.2.3 will say write down the balance equation using molecular formula for the complete combustion of Q. Q is ethene. Ethene, if we talk about complete combustion of ethene, it will be C2H4, and then we need oxygen to produce carbon dioxide plus water. Now, if you remember, you can put 2 here, and then number of carbons here, hydrogen becomes the coefficient here, and then carbons, this I can put 4, and then oxygen's 8 plus 4 is 12, divided by 2 is 6, and then that I can write it this way, or just write just C2H4 plus 3 oxygens forms 2 carbon dioxide plus 2 water. Remember, balancing can be multiples. That one is allowed. So 4.3.1. 4.3, they say reaction 3. Reaction 3, we remember we said it's your addition. Write down the type of addition reaction. Because we're adding hydrogen, then it's hydrogenation. Hydrogenation. And then 4.3.2, write down the chemical formula of the catalyst used. Chemical formula, you can write platinum, you can write nickel, you can write palladium. It's fine. 4.3.3, that's the last question in this. Write down the balance equation using structural formulae for reaction 3. It's starting from ethene, 1 double bond, hydrogen, 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 hydrogen. We add hydrogen here. It will be now 1, 2, hydrogen, 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 hydrogen. That is the balance equation using the structural formulae. No problem. Remember, in the case of hydrogen, you can accept if a learner just write H, a double bond H. So though it's inorganic, it just have to be H2. Good. And then we can move to the next question here, the next stop, which is our question number 4, which will be now the reaction rates. Reaction rates. Let's see the reaction rates question, which is very vital in this case. Look, let's flip the page and then say this. We are here. We are on this one. Now we are given this Maxwell-Boltzmann distribution curve from the 2 scientists, remember. One was the implementer, which is your Boltzmann. The other one was the initiator. Maxwell-Boltzmann distribution curve as below represent the number of molecules against their kinetic energy for a certain reaction to study reaction rate. Graph P represents the original graph before the changes were made to the factors affecting the reaction rate. Yes. Now, the first question in this case, question number 5. They're saying to us, define the reaction rate. According to the examination guideline, reaction rate is the change in concentration of reactants or products per unit time. Otherwise, other people can just use that one of your average rate equals to delta C M N V divided by this one. So you can explain using this one, change in concentration of products or reactants per unit time, change in the mass of the products, reactants per unit time, change number of moles. So that's numerous. That will be also accepted. Now, what does the area under the graph Q represent? All the areas under Q, under P, under R will be representing the total number of molecules in the system. Then 5.3, the graph starts at the origin, yes, at 0. Explain this observation. It means that now in relation with this concept of Maxwell-Boltzmann curve, it means that now no molecules have zero kinetic energy. That's why it has to start at 0, because now at the origin, when you start the reaction, if there are no molecules, there will be no energy. So once you start having molecules, then the energy must be greater than 0. In this case, 5.4, which portion, another explanation for that one will say, this every molecule, because the whole range of molecules now, they are moving, no molecule is stationary. So that's why it might have the lowest energy, but it should be closer to 0. It will never be 0. It's like here at the end, the graph will never touch the horizontal axis, because we will always have molecules with the higher energy. So we can't have molecules that will have 0 at the end. No. So 0 we won't have no molecules here that will be having the high energy. So we'll always have few molecules that will be having the higher energy in the system. Now 5.4, which portion, A or B, has molecules with unsuccessful collisions? Unsuccessful collision must be lower than activation energy. It will be A. So the answer is A. Explain, then the reason will be that one. So they have a kinetic energy that is lower than the activation energy. Fine. 5.5. To obtain graph R, a change was made to the original reaction. What effect did the change have on the following, rather than increase, decrease, or remains the same? To obtain R, obviously the R leaning backward, means that the temperature was decreased for R. Therefore, if we decrease temperature, now what will happen? The total number of molecules, they remain the same throughout. Remain the same. Fine. 5.5.2. The number of effective collisions per unit time. Once the temperature is lower, then that one would mean that now the number of effective collisions per unit time will decrease. Fine. 5.6. To obtain graph Q, that's Q, it means that the concentration was decreased in Q. Yes. Change was made to the original reaction, rather than the change made to obtain Q, and that now concentration decreased. Concentration was decreased. Fine. Now we need to explain, I hope. Use collision theory, yes, to explain the effect of the change on reaction rate. When you decrease concentration, the most important point, first point, will be now number of molecules or particles per unit volume decreases. Yes, once there are fewer molecules, then it means that now less molecules collide with the number of molecules colliding or molecules colliding with correct orientation. Correct orientation decreases, or you can say less molecules, or molecules with enough kinetic energy. Molecules with enough kinetic energy decreases as well. I can write that one as well. And then now the third point, yes, therefore effective collisions per unit time decreases, and then the last point will be also reaction rate decreases, because they say what will be the effect. Reaction rate decreases. So hopefully you've got many options here. What you need to do is that the first point that everyone must have in this case, the first point that everyone must have is this one: the number of molecules with per unit volume decreases. That will be 1 mark. And the last point that everyone must have is this one: the reaction rate decreases, because the question says explain the effect of the change on reaction rate. So reaction rate decreases. And then these three, either molecules colliding with correct orientation decrease will be the third mark, or molecules with enough kinetic energy decreases will be another alternative mark, or effective collisions per unit time decreases. So any of these three will get the third mark. I think it's understood in this case, answering the question accordingly. I think this one brought us to the end of this reaction rate. Very important. Remember, in most cases, the concept that is also should be taught here to say, in this collision theory, remember why the graphs start from 0, that now no molecules, all these molecules in the system, no molecules is having 0 kinetic energy. That's the case. So, or why the graph does not touch us here is that now we'll always have few molecules that will have the higher kinetic energy here. So we won't have a situation whereby no molecule is having the highest kinetic energy. So that's why the graph will always not touch the horizontal axis. Yeah, all set and done. Very important. I hope learning few things, and every time when we are having this engagement, your information and knowledge in the subject increases, which is my gratitude on that one. So my happiness is derived when people who gain knowledge in the subject. So until we meet again in the next sessions, don't forget to subscribe so that you are always on par with the latest uploads. Thanks a lot, and spread the gospel. Science is fun. Thank you. Bye.